Welcome, everybody. This is the ISE part of the presentation. I'm Dr. Natalie Chewbacca, and I'm faculty member in ISE and our undergraduate program director. And here with Jacob. Go ahead.
And good evening. My name is Jacob Kirsteins. I'm one of the undergraduate academic advisors for the ISE program. So first off, we just want to say welcome to the Grado Department of Industrial and Systems Engineering. We're really excited to share with you what industrial and systems engineering is. So we really, I would say, kind of have an identity problem within industrial and systems engineering about what is ISE. And so what ISE is not, is it's not just factories and steel-toed shoes. We work in a plethora of different areas. ISE is truly everywhere, from hospitals and sports analytics to theme parks and tech startups. We really have our hand in every different field that you can think of. And what we do is we make complex systems work better. So thinking of streamlining hospital operations, designing safer cars, or optimizing airline schedules, ISE really is all about integrating all of these different technologies, data, processes, money, and people to create a solution that is faster, cheaper, better, and safer. So we want to look at not only our bottom lines, but we also want to look at the people. So we integrate technology and people into one area. We also work with cutting-edge technology. So from AI and robots, VR, AR simulations, wearable tech, data analytics. So think of the Apple Watch or Samsung Watch on your wrist, to the phone in your pocket, to investments and banking. All of those have big data, and a lot of what ISE is looking at are those data analytic points that we can point to and engineer solutions for. So we're shaping every part of your life that you experience. You just may not be able to visually see it because of a lot of the processes and solutions that we come up with, you actually experience. You live through it waiting in the queue at the airport. You see your package from Amazon being delivered to you. But that's all you really see, is the product that you received through the process that ISE solved for you. Within the ISE program, we have the flexibility and customization possibilities of focusing in 4 different program areas that Dr. Chewbacca will be going in depth on a little bit later. But manufacturing systems, your traditional idea of manufacturing a product, to management and systems of working with teams, understanding how those teams are being integrated into different solutions, to how many people should be on a manufacturing floor line. So a lot of times we think about this in the ideas of consulting. Operations research, the mathematical backbone of what the ISE program does. So how do we look at all of these data points? How do we look at different people and say, quantify this data, optimize it, streamline it, come up with the most perfect solution, because you'll never come up with the perfect solution, but the most perfect solution. And then how do we then integrate it and implement it into that workplace? And then human factors and ergonomics is going into that. How do we integrate people into technology? So think of AR and VR. Think of your car. Think of, is your seat comfortable? Is your seat that you are sitting in comfortable right now? Or should it be ergonomically designed to fit you better? And how do we do that? It's a solution that industrial and systems would look at. And so your skills can apply to nearly every industry. And one great thing is employers love to hire ISE grads. Companies love the idea that you look at the big picture of things and see how things are being integrated across the board, to apply your systems thinking ideas to solve problems and create solutions. So again, it may not be the tangible product that you have in your hand, but how it got there is how we engineered it to be there. So it leads to high job placement rates and competitive starting salaries. But really, what is ISE? So we have a short video that the department has worked to create with some alumni, some current students, and also our department head that hopefully explains it a little bit better.
Industrial and systems engineering is all about efficiency. It's about looking at complex systems and really figuring out how can we make them better, how can we better understand them.
I would say industrial systems engineering is everywhere, from the cars you drive to the cell phones in your pocket.
I usually like to start by saying it's the combination of business and engineering all in one major.
ISC, we look at things and how to make them better and more efficient, whether it's the people within the industry, a facility, a layout, or trying to figure out how to reduce cost. We look at things and make them better.
That can be applied to any industry, whether it's finance, healthcare, business, manufacturing. So ISCs are really in need in any industry.
Within ISC, we really like to optimize things. So we're often thinking and applying our tools and our systems thinking mindset for how to make things faster, cheaper, better, and safer. And so that's kind of a mantra for us, is we're always looking for improvement opportunities.
I love ISC because of how broad it is and how many different career paths you can go into. And so if you have an interest in automotives, aerospace, makeup industry, consulting, anything like that, ISC has a home for you there and so many opportunities within it. I know that within ISC, our graduation rate last year, I think was 95% of our students had a full-time job offer or a master's opportunity. And so you get a bunch of opportunities when doing ISC and can go into any sort of career that you want to as well.
Industrial systems engineering has 4 core areas. That would be management systems, operations research, manufacturing, and human factors.
So we're the kind of engineering discipline that brings all of those pieces together. And we might do that within a manufacturing facility, like where equipment is laid out, how many people do we need, what kind of inventory levels, what is the production schedule. We also apply our toolkit to entire supply chains. So if you consider your portfolio of suppliers or vendors, and then what goes on in the facility, your distribution network and customers.
Industrial systems engineering is kind of more of a mindset than a discipline, because I find that I use it a lot in my life outside of the classroom.
What's special about ISC at Virginia Tech is that we have faculty with expertise in all areas of ISC. That's not always the case.
And we do this work in a work system that might be one that creates a physical product. But what I also think and always have been fascinated with about ISC is that we do the same kinds of things within a work system that produces a service. So our students are skilled at being able to go into a manufacturing facility, a distribution center, a package delivery system, a bank, a hospital, a theme park, and in the entertainment industry. So the skill set that ISCs bring to companies and to the world is very transferable across all of those kinds of different kinds of businesses and sectors.
I think they can expect to get involved in graduate student research, and then as they gain more experience, I think they can take on their own projects. Many times students get the opportunity to also present their work at conferences either here at Virginia Tech or professional conferences in other locations.
I really like doing hands-on learning because it really translates to what it's like in the real world. And so getting to learn about the Learning Factory and getting to work within it was really cool because I got to see how cobots are used. And that was a really cool experience because at Honda, where I previously did a co-op at and I'm working full time, we actually have cobots in the real world there. And so it's really cool to see how like different machines and everything like that are applied. And then with the exoskeleton lab, it's really cool to see how different software such as MATLAB and Excel are used to solve real world problems.
If you tend to always look at the world as how can it be made better, how can a process work more efficiently, whether you're at a restaurant or whether you're in a hospital or your bank, or if you are looking at any kind of process and like, I think that could work better, then ISC would be for you.
All right. It's a little bit tough to follow, but nonetheless. All right, so I'm going to tell you a little bit about the 4 program areas and maybe what you'll be studying in the ISC program. So these 4 areas, the first one, manufacturing systems. And this is the traditional application area of ISC. And so we look at designing and improving a facility and the operations within that facility. And so in comparison to a mechanical studies, we're looking at the higher level, at the whole facility, how it operates, how do we integrate the different machines together? How do we integrate the people into those machines? And so you see some of the topics up here. These are some of the research areas where faculty are working and some of the applications. And so you would have the opportunity to do some undergraduate research and some technical electives in some of these areas. The next area is operations research, and this is the mathematical side of ISE. And in this, we're looking at lots of simulations, big data, AI, predictive analytics. And in this, what you can kind of think about what we do with operations research is just a giant story problem. So instead of a couple variables, you've got 10,000 variables that we're trying to optimize. And so we look at how can we do this efficiently and effectively. And then once we get this modeled, we can play what-if scenarios and consider how we might change different factors of our system and what the potential outcome would be of those. All right, the next one, human factors and ergonomics. See at the top, observe, evaluate, and design products or systems that increase our user efficiency and well-being. So what we're looking at here is how do people interact with the system, and how can we design a system to accommodate and to leverage people to the highest degree. And so in this, you'll see like user design and AR, VR, again, wearable tech, and some of the research that you see up here on the screen. Management and systems engineering. So this area, we're going to design and improve systems used within a management or within a business and beyond. And so this looks a lot at an entire system and how people might behave within that system. How do we form teams? How do we respond even in any sort of system? It could be healthcare. We have a lot of our management systems faculty that work in healthcare, and the different complexities and modeling those different complexities, again, using the operations research, but this one relies a lot more heavily on business and people and how they interact with the system from a mathematical point of view. All right, so the curriculum itself captures all four of those areas. There's some of the courses you see there at the top that are just the general ISE courses. And then the four different areas, you see that you take a few courses in each of those areas. And then there's still room for you to specialize or to get a little bit extra in the tech electives and in one of those specific areas that you find interesting. Okay, so I'm going to wrap up my section soon, but this is the official definition of ISE. So we spent a lot of time kind of trying to explain to you the different application areas and what we do. And from our professional organization, the Institute of Industrial and Systems Engineers, this is the definition. It's the design and improvement. So you've heard lots of that, and what are we designing and improving? We're designing and improving complex work systems. And those systems involves people, materials, information, equipment, and energy. And so the huge benefit of that is a system can be anywhere. A work system is anywhere. And so the sectors and the application areas of ISEs is practically endless. And so there's a lot of opportunity that you can pursue what interests you with an ISE degree. So a few examples of our recent graduates and some who have been in the field for a while. So you see up there in the top left, Gordon, he works for Booz Allen as a data scientist. Colleen in the middle works in healthcare as healthcare consulting. Sydney Weeks, who you saw in the video, she just graduated. You see her internships listed up there with Collins and PwC. She's now working for PwC. Colleen Craig in the bottom corner is the lead industrial engineer director for Disney World. Matt Davis in the middle is in UX design. And then Mickey Ross is a current student, and you see her internships up there with United Airlines and BMW. So lots of variety, different sectors and applications you can go into. So I'm going to pass it back to Jacob to wrap us up here.
All right, so hopefully we kind of painted a picture about what ISE is, what you could possibly do with ISE. So what we kind of want to wrap up with, why? Why should you pursue industrial and systems engineering? So a lot of our Majority of our students, so obviously more than 50%, but we'll quote a number around 85, complete some type of co-op or internship opportunity while they are with us. So this is a sampling of those companies. You'll see it does range from the consulting world to the aerospace industry, automotive industry, entertainment over at Disney, consulting, healthcare, banking and finance. I think that was one of the biggest shocks I had when coming here, is to hear that engineers were working for Goldman Sachs. They were engineers, they were ISE students. Undergraduate research. With all 4 different areas and a depth of that, we have a significant amount of undergrad research opportunities for our students to go into these different areas to really kind of begin understanding, well, not what's happening now in the past, but researching what is really going on in the future. So thinking of AI and AR, VR, what's next? What does that research kind of look like? So what's going to be implemented in the next 5, in the next 10 years? It's so rapidly changing. You could be on the forefront of that to see what that's going to look like. International experiences. We highly encourage our ISE students to seek out some type of international experience. You know, looking at global supply chains and understanding a complex system. It's not just your individual workspace at your desk at your one company. It is an international working environment. And so going abroad, understanding how different cultures work, how different people interact, gains you to be a better engineer when you begin working within those spaces. But really, for industrial and systems engineering, we are excited to see that the best jobs, according to the US News and World Report, is ISE is the #1 best engineering job currently in 2025. So we're proud of that, to see that ISE is in high demand across the board for all of the industries that we've talked about, with an 11% job growth rate over the course of the next 10 years. So you are nearly all freshmen looking at what's going to happen in the future. Well, we can say for ISE, you have a great opportunity on your return in majoring in the program. We also have a messed up number, but that's okay. That says $80,000 as a median starting salary. So great starting salary, but look at the top 10 highest paying majors. 4 of them, of the top 10, fall within the world of ISE 10 years post-graduation. So not only are you looking at a great starting, you're looking at a great future as well. And we are also the #4 program of ISE in the United States. So you're at a top engineering school at Virginia Tech, you can join a top ISE program as well. So we just want to say thank you, and we will be in the back afterward to answer any additional questions. Thank you.
All right. Good evening, everyone. It's a great honor to be here. Special welcome to everyone who's here to know about mining, and welcome everyone else as well. A quick show of hands for how many of you, this is the first time we learned something about mining. Awesome, this is great. With that being said, I'm Rohit Pandey, Assistant Professor in the Department of Mining and Minerals Engineering here at Virginia Tech. And not too long ago, well, about 15, 16 years ago, I was in the same position. That's why I'm going to start off talking a little bit about myself and what my background is. I come from the other side of the world. I grew up in Calcutta, India. I got my bachelor's degree in mining engineering over there. Calcutta is a city of about 20 million people. I grew up in a city life, knew nothing about mining, and you know, like I knew about mining when I got to university. And that was the second best professional decision I've ever made. Since then, I moved out west, came to the US, started grad school in beautiful Southern Illinois, went to SIU Carbondale, got my master's and PhD in mining engineering, and I had a decision to make. And the decision that I made was I'm gonna actually go work in the industry, right? So then I moved to Alabama, worked about 2,000 feet underground in a longwall coal mine. We were actually mining under a river, and we were pumping about 1 million gallons of water every day. So that was incredible. I worked as a mining engineer, worked very closely with real-life projects, dealing with mine plans, mine designs, working with miners underground and presenting plans to corporate leadership. So it kind of really opened up my world to what really mining is. In that time, I got opportunities to explore my horizon a little further, so I moved further out west, went to Nevada, worked in an underground gold mine, about 1,500 feet deep in northern Nevada, and over there, the job was a little different. I found myself in front of a computer, drawing a bunch of mine plans, mine designs, understanding economics, finance, and presenting these plans up to corporate management, but at the same time being really tied to the operation background that I came from. So after that, I took the best decision of my professional life. I moved out here to Blacksburg, and I'm really happy to be a Hokie. And what I know is you all probably have made the best decision many years ahead of me because you are here now. This is probably the best decision that you could have made. You're setting yourselves up for an awesome career no matter which field you choose. So with that background, I really want to introduce mining to you. And based on my experience, what I found out is oftentimes people have a lot of misconception about mining, right? So we don't really know what mining is. It's a very niche field with a very broad application, right? So we're going to start off with some mythbusters, right? So if you heard about mining and you're like, hey, isn't that a part of a dying field? Who really goes to mining? Do mining engineers really exist? Or do we just see that in the movies, right? I mean, isn't that the major that I'm going to live in the middle of nowhere with nothing to do? Or, I mean, I'll have limited career opportunities, and when I come back home from work, I'm going to look something like that. That was the old days. I mean, pictures like that belongs to museums in big mining operations these days. And the real reason for that is we have to take a step back and think about, as a society, where are we heading? In today's society, we are growing to be a sustainable society, but we are driven by a lot of energy requirement, a requirement for technology. No matter where we look, all of these technologies are deeply rooted in our immense need for a lot of minerals. Okay, the world starts with mining. We need these minerals to build the world that we live in, and the energy demand and the demand for things and resources are just increasing, right? So when you think about a dying field, that's definitely not mining, because mineral resources are the root for our advancement and survival in the society, and modern technology requires a lot of minerals and elements that we didn't even think about. An example, recently we had the iPhone 17, right? So the iPhone 17 needs about 75 elements of your periodic table. Where does that come from, right? In contrary, if you think about a human being, and here we have Dr. Aaron Noble, our department head, who's working in his lab. As a human being, we need only 27 elements, right? So in some ways, our need for technology and need for sustainable living requires us to be able to get access to these resources and mine these resources in a sustainable and an advanced manner, okay? So with that being said, oftentimes people ask, hey, mining, do you mine with a pickaxe? Do you have to go to work with a pickaxe and a shovel packed into your bag? Well, I will let you decide for yourself. So here you can see two of the largest mines here in the US. The one to your left is the Morenci mine in Arizona, mining copper, and one to your right is the Bingham Canyon in Salt Lake City, Utah. Bingham Canyon can be seen from the International Space Station, right? And you tell me how long you're going to take to mine a pit that size with a pickaxe, right? For reference, if you see those small trucks right there, let me do this. If you see these small trucks, you would think they are your pickup trucks, but they're not. They're giant haul trucks that's carrying about 300, 400 tons of material from in and out of the surface pit, right? So for reference, here is me at Nevada Gold Mines doing my job between the two axles of a giant drum truck, right? And that was not even the biggest truck that we had, right? So here's another perspective. Here is an engineer next to a giant dump truck wheel. You can buy a few luxury cars for the price of that tire, not even the truck, right? You can probably buy a couple of jet planes for the price of that large 797. So now that's not limited to surface mining, underground mining, where we actually build tunnels to go underground because we don't want to open up a pit that large. You are not crawling into that underground mine. So this is a salt mine from Eastern Europe, and here for reference, you can see a person standing right there. So you can imagine how large these mines are. They are technologically intensive, and you probably don't have to go to Poland to go to a mine like this. 30 minutes drive from where we are right now, we can go to Kimbleton Mine, and here you can see a full-size school bus taking our students to a field internship or to a field visit where we are learning about the mining process, right? So it's right here, mines are right next to you, we see these every day, and for perspective, here's another image where you can see a man perched up on that top entry while a drill rig is working to get more mining done, right? So here, we also have Dr. Richard Bishop, who is a professor of practice at Virginia Tech, flying a drone, right, to get where we get to integrate advancements in technology to make mining safer and more sustainable. So in many ways, mining is the proving ground for modern technology. So with that, this is what a real mining engineer one can imagine. This image is, of course, AI generated, but if I were to show you what real mining, current mining really is, here are about 15, 20 dump trucks that's carrying material out from a giant pit, right? So you can see some of these dump trucks are full of material and the empty dump trucks are going down the pit. Not one of those dump trucks has a single operator. It is all autonomous. There is no one driving those dump trucks. It's being managed from a central control room. There's a whole bunch of unit operations that's happening further down the pit. There's no one working on those equipments either, right? So the operations are autonomous. It's cutting-edge technology. So if I ask you what is mining, well, mining is safe, we are cutting edge, we are technology-driven, and of the grandest scale, right? So, and most importantly for everyone over here, mining, we are hungry for talent, right? So we need people to work with us so that we can keep moving the world forward. So with that being said, you might have a question, hey, if I'm in mining, where will I work? So here we grabbed the image or locations of all the mining operations in the US, and we kind of created a map. And if you see the active map of mining operations, it's pretty much the map of the US. Compared to the regular myth that goes around, most of our graduate students or most of our department graduates actually live close to where they grew up. They live in outskirts of big cities, but if you want to go out, work out west or in a big mine at some remote location, you would have those opportunities too. There are mines everywhere. We do such a good job that you just don't see them, right? And now you don't want to work in the US, you want to be a high-flying jet setter, be a globetrotter. Well, those opportunities exist worldwide. There is a massive need for engineers worldwide in mining operations that we can't just fill in. As a matter of fact, in the gold mines I worked in Nevada, of the 30 engineers, 26 were from countries around the world because there is such a high demand for top-tier mining talent in the world, okay? So having said that, you might have a question. What do mining engineers do? What does my daily life look like? Well, there could be a range of things that you could be doing as a mining engineer. You could be working on exploration, where you're trying to find out where am I going to mine, and you're going to be drilling tiny holes into prospective deposits. And if you hit gold, then, well, your next few generations are taken care of because you've made a lot of money, right? So once you find a ore deposit that is mineable, and then begins the big process of thinking what's the best way, the most sustainable way, and the economic way to be able to extract that resource. So sometimes between exploration, development, actual beginning of construction, it might take decades because we want to make sure that we are doing so in a sustainable way. Once the planning is done, then we start breaking ground and we go through the entire process of managing these operations, making sure we are moving material, but at the same time, we want to make sure we are taking care of Mother Earth. We want to leave our mine during closure. That might be a few years down the road, a few decades down the road, or maybe a century down the road. We want to leave the place better than we found it. So as a mining engineer, you could be associated with any any part of this process, and as you can imagine, that would involve a variety of jobs, right? So if you think about what mining engineers do, you could work as a mine design engineer where you're designing mine layouts, planning based on your finance and economics of spending a lot of time in front of a computer and working closely with operations. But if you want to be a hands-on person, you're then heading underground, being involved in actual mining. You can work as an operations and production engineer. If you like to solve matrices and solve statics and dynamics problems in your spare time, you can work as a geotech engineer and understand how rocks move and behave, right? At the end of the day, we still have to get the element out from the ore that we mine. So if you like chemistry, you could be working as a processing or a metallurgical engineer. Mining is large, sometimes it's hazardous, so there is a lot of work on health and safety that engineers work on. We are working with the environment, so there's a lot of environmental engineering roles that often mining engineers find themselves working on, and so on. I kind of don't like this slide because it kind of limits your thought to what the possibilities are, but in reality, the possibilities are endless because we are rooted in the ground truth. A mining engineer who comes out of VT and who comes out of industry is a very well-rounded human being because they have a very practical understanding of how the world works, right? So here's a quick video of what a daily life for a mining engineer in the field would look like, and this would be pretty awesome. That's a blast design that mining engineers get to work on, designing amount of explosives that you're going to use, how many holes you're going to put in, but also how you're going to time the explosives so that you don't shake the ground, you don't disturb your neighbors, right? So there's a lot of engineering, a lot of thought and control that goes into applications that seem as simple as this. So this could be a very cool application that you're working on as a drill and blast engineer. As a matter of fact, I'm going to come to it, but on October 8th, we are taking a group of students. Everyone's invited to sign up where we go see a blast in Roanoke, and we call it Blast Day, okay? So I'm going to talk about that again. But overall, as a mining engineer, you could choose the field that you want to work on. If you want to be a manager, in management, if you want to be an engineer, work in engineering design, you can be associated with environment, data analytics, entrepreneurship, finance. You could be doing anything that you like. An example is Dr. Richard Bishop, right? So Dr. Richard Bishop is an alumni and currently a professor of practice here at Virginia Tech. He started his career working as a finance research analyst at a big bank in Royal Bank of Canada, right? So he was working in the high rises of Toronto, making financial decisions because a mining operation is a multi-billion-dollar investment. There's a lot of money that moves around, so there's a lot of financial engineering that takes place. Or you could be like one of our recent graduates, Sam, who works as an environmental engineer with Tesla in front of the cutting-edge technology. Or you could be like my good friend Tyler, who everyone in the mining industry knows because he travels everywhere and solves their practical problems using his software solutions, right? Or as you progress through your career, you can be someone like Carrie, who's the president of beverage packaging at Ball, right? I mean, if you have drank Coke from a can of Coke, there's a 50% probability that was made by Ball. And although you would think that how would mining engineers end up there, it's the practical experience that you gain through exposure to real life problems is what gets you to those positions of leadership, right? So hopefully that gives you some perspective about mining, and which it is also important to talk about Virginia Tech. What about mining at Virginia Tech? Well, over the last decade, a quarter of the engineers who graduated as mining engineers in the US were Hokies. So if you go out there at your workplace, you're going to find a very familiar face, or you'll be able to associate it with a very familiar feeling, right? Because Hokies make the US mining go around. We have been voted as a university exemplary department in 2021 for engagement in student success. And we also value diversity. 30% of our 2027 graduating class is female, so everyone is welcome. As far as curriculum, in mining, our curriculum involves a hands-on, application-based approach. We work very closely with industry. We have specialized leadership courses. As a matter of fact, next week, a group of students is heading over to Caterpillar in Illinois to take an intensive course on leadership where we are trained to be how to be world leaders. The students get opportunity to work on multi-year engineering design projects that are very practically oriented and also has a range of tech electives. Uniquely so, mining engineering is one of the most research active departments in the College of Engineering and at Virginia Tech. So each and every student will have an opportunity to be associated with research if they choose to do so. But here's the fun part. I mean, the question is, what about job placements, right? Well, mining, we have our own career fair, which is coming up very soon, and it is hard. It's hard for our students because oftentimes they can't really choose which job offer to take, right? Because that's the reality of it. I mean, I have, not only at VT, in my career of 15 years, I have never seen a mining engineer who was stressed about not finding a job. And it is more so the truth for us here at VT because we are probably one of the best mining schools in the world. We have nearly 100% internship and job placement records, and scholarships are usually available to any student greater than a 2.0 GPA. And the reason for that is we are a fairly small department. Our class size is typically 30 to 40 students, but in our career fair, we have about 60 plus companies recruiting students. So you can do the math, right? So that's the reality of it. The world needs a lot of mining engineers. Our work is really rooted in ground truth. It's everywhere, and we need you. For a small department like us, the rankings work a little differently, but the discipline itself has been recognized by multiple agencies as one of the highest paying departments or engineering majors that one can pursue. Here by CBS News, it was ranked number 8, and the numbers keep on increasing every year. Especially at Holden Hall, we have world-class facilities. The Holden Hall is one of the newest buildings on campus. We have cutting-edge technology. The technology that we use to teach in Holden Hall is what industry uses. So we are very driven by the current standards and drive technology as well. So there is only so much learning we can do about mining in this setting. So please come and talk to us. And if you want to go visit an awesome blast with us, we are organizing a blast day field trip. This is actually the second field trip. Feel free to grab that QR code from the screen. On October 8th, we are organizing a field trip to Roanoke Quarry to watch a blast and learn more about mining, but we do have limited seats. So in that case, if you run out of space, don't worry. We do organize free lunches. So if you want to come meet with us, get some free lunch, talk to students, faculty, scan that QR code, sign up for a free lunch, and we will learn more about mining, right? And most importantly, for first-year students, if you want that real head start, we have our career fair, October 21st. Mining companies do hire first-year students for the internships. I myself have mentored first-year engineering students when I was in the industry. And the head start that they get in being able to then translate classroom learning to real-life applications through the course of their career is incredibly useful. So I encourage everyone who's interested in coming to the career fair, please sign up on Handshake, use this QR code, and I guarantee you there would be someone waiting for you. And most importantly, if you have any other questions, just let me know. We also have our academic advisor, Michelle. We will be around at the back of the hall after the session's over, and we are also giving out free shirts, right? So with that being said, it's been an absolute pleasure. I wish the best of luck for everyone. Thank you very much.
Okay, good evening, everyone. My name is Dr. Christine Gilbert, and I'm an associate professor in Aerospace and Ocean Engineering. Today I'm going to talk to you a little bit about ocean engineering, and it's probably a little bit hard to follow all of the cool blast videos and free lunch and free t-shirts. So anyway, I'll do my best. So one of the things that you may be wondering is, what is ocean engineering? Ocean engineering is something that there's actually not a lot of programs dealing with ocean engineering or naval architecture around the United States. However, one thing to note here is that the U.S. Navy is one of the most powerful navies in the world, and we want to try to maintain that superiority. And so in order to do that, we really need very good engineers in order to help design the next generation of ships, submarines, and other types of watercraft. Many of the ship designers that are employed by the Navy are retiring or have retired, and there's no clear path to who's going to take over all of those jobs. And so we need you to, if you're interested in designing boats, to take some of those positions, come to our major and take some of the classes, and you could be well positioned for something like that. Ocean engineering, we study vehicles that move fast through water or on top of the water surface. 90% of goods are transported by ships, so your Amazon packages, if you're purchasing something that was made in China or Japan, those are probably going to get to you by ship. Marine renewable energy is an untapped resource, especially with all of the waves, and the 71% of the Earth's surface that's covered in ocean. And then the US Navy has a very, very large budget for research and technology. So if you were to major in ocean engineering, what kinds of things would you learn? And most of our curriculum is geared towards methods and tools in order to enable you to basically design an entire ship or a submarine for your capstone design. I think in some cases, some students have also designed small sailboats or yachts. And all of the background information that you're going to be learning is going to help gear you towards that project. So if you are interested in ships, if you're interested in sailing, if you're interested in anything on the water, I do strongly recommend that you consider this major. One of the things that's really important in picking a major is making sure that whatever you're doing for your capstone design is something that you're really excited about. So if you're really into boats, or if you're really into submarines or diving, maybe this is the right major for you. We do a lot of things with fluid dynamics, structural mechanics, dynamics and controls of different vehicles. There's also a lot of CAD modeling, FEM, and CFD calculations that can be done. Some of the other topics that students will learn are things like hull forms, stability of a ship. So you can imagine if you're on a ship and it starts rocking back and forth, there could be some kind of seasickness issue, and so stability is something that's important. Also, the hydrodynamics is extremely important. That's going to be the water and the interaction with the waves. Structures and materials, we want to make sure that our ships don't break, especially when they're operating in waves. And then we want to make sure that we have good propulsion characteristics and that we can go fast. Vehicle dynamics and oceanography are other topics that students will learn in the curriculum. There's also a couple of design teams that students could join that are related to ocean engineering. And I've highlighted two of them here. One of them is the Virginia Tech Sailbot team, and the other one is the Human-Powered Submarine team. And Maggie Campbell, who is on the Human-Powered Submarine team, is going to be one of the students on the panel this evening, and she could tell you a little bit more about the Human-Powered Submarine team if you wanted to talk to her later. The Human-Powered Submarine team is a fully flooded submarine that is going to be driven by human power, so either some kind of pedaling of your feet or pedaling of your hands. And because this is fully flooded, that means that it's going to be completely encased in the water, and so the pilot and all of the support people who are going to be helping with the testing of the submarine are going to be scuba certified, and that's something that the team works on to get their members scuba certified. Other things that are really exciting in the department are the research activities of our faculty. Many of our research projects are sponsored by ONR, which is the Office of Naval Research. And actually, even in between the aerospace and ocean engineering side, both sides of the department, ONR is still our top funding agency. We also have funding from Navy Labs for the ocean engineering side, National Science Foundation, as well as industry. And there's many students. I think Maggie also was enrolled in the AOE 4994, which is an undergraduate research credits, where she can work with people like me in the lab to learn a little bit more and enhance her skill set. And one of the great things about undergraduate research is that it's a gateway to grad school. So if you're thinking about going to grad school, that is something that you want to consider doing, whether you pick ocean engineering as your major or not. The other thing is that you can use this as research credits to basically replace a technical elective. And in that case, you're really going to be customizing what your curriculum looks like. Some students can have opportunities to be paid through research assistantships or fellowships. The National Science Foundation has a research experience for undergraduate students. And it's also just fun to be involved in building some of these things that we're going to be testing in the lab. One of the things that I forgot to include in this presentation is a video of our towing tank facility. Our towing tank is a 100-foot basically a very long, narrow pool that's in Norris Hall, just over there in the basement. And we have an instrument carriage on top that you can use to mount a model and have it move down the tank. And what we can do with that is assess different performance characteristics. One of the other cool things that we can do is leveraging the fact that we have aerospace and ocean engineering in the same department, we can try to get creative about looking at the interface between the two majors, such as things like seaplane landing, seaplane takeoff, or water entry from space capsules that are coming back to Earth. So many students in our major get summer internships. There are a lot of jobs, especially compared to the number of graduates. I don't have exact statistics for that. One thing I do know with my involvement in the American Society of Naval Engineers is the fact that there are a lot of scholarships that are available for undergraduate students, but because there's not a lot of applicants, they end up giving them to students of other majors that are not ocean engineering, and so there are a lot of good opportunities for students. And then there's a lot of different job opportunities. A lot of them are sort of Navy-driven, and there's other shipbuilding industries and so on that students can work at once they're done with school. And another option is grad school. And one thing that I think hasn't really been talked about too much is the option to go to graduate school. Many students do choose to go to graduate school. You can either pursue a career in research or academia, or you could work at a government lab. Maybe the government lab situation's not so good right now, but maybe things will get better. We have a UGG program, which is an undergraduate-graduate program where you can add 1 year to double count up to 4 classes in your senior year towards an MS or PhD degree. A master's program allows you to get deeper knowledge within your major, whereas a doctor of philosophy or a PhD is going to make you an expert in that field. I would say that a PhD allows you to work on projects that interest you, whereas with a master's degree, you might have a higher starting salary, but you may not get to work on exactly what you're interested in. Some of the other career opportunities in ocean engineering could be in renewable energy. There's also the obvious oil and gas. Other things in remote sensing. I really like the diagrams that are shown on this particular slide, just because it really wraps together the aerospace and ocean engineering parts of our department together. This slide might be a little bit outdated, but there are very good job opportunities and high starting salaries and salaries, as well as very low unemployment rates in this particular field. And I think I'm going to, at that point, turn it over to my colleague, Dr. Atkins.
Hi, just to tie things together, I'm Dr. Ella Atkins. I'm the department head of Aerospace and Ocean Engineering. My background is mostly in aerospace, so I've been learning a lot about ocean engineering, and it's really exciting. One of the things I see are people from the different companies coming here and also the government agencies, and they really are saying a lot of the same things that we heard from Dr. Gilbert and from the mining presentation, which is we need more ocean engineers. How do we get these people to choose ocean engineering? So I'm looking at you guys saying, I tell you, if you choose ocean engineering, you will have a choice of jobs. A lot of them are on the coast. Just yesterday, I was meeting with some folks from San Diego who were saying, we can't get enough Virginia Tech people to apply for our jobs in San Diego. So please think about that seriously. Now I'm going to move to aerospace. I've loved aerospace since I was a kid. I grew up around here, and there were fighter jet pads that trained low over my house, and there was nothing more exciting than an afternoon than looking up in the sky. I'm pretty old, so there were no F-35s back then, but there were things that were still cool. Today, I suspect most everyone in this room has been somewhere across the world or across the country where you've been in an airplane. The first time you fly, it's pretty exciting to sit there and think, wow, I'm going to be going several hundred miles an hour before I ever launch into the sky. And then you get into the sky and you climb a little bit and you're like, wait a minute, it feels like I'm sitting in my living room. Well, that's pretty cool, right? You're going several hundred miles an hour, almost the speed of sound, safest form of transportation, including everything on the ground. And you get across the world in less than half a day in most cases. Well, that wasn't by accident. We started with the Wright brothers and others in the very early 20th century. And between all of the different pieces and parts that you see on this cartoon, we are able to travel across the globe for a pretty low price, as long as you're willing to sit in coach class between some other people, today, and feel perfectly safe. I sleep on planes all the time, and I'm sure some of you do too, or else watch videos and barely realize you're flying. So this diagram is basically saying what it seems like before you enter the major and take the technical courses. So, well, when you're sitting on an airplane, it seems like magic. There's air flowing over the wing, and somehow you're lifted up into the sky, even though there's tons of metal, composite materials, people, fuel, and other things. Well, in the rocket, kind of the same way. You see some exhaust coming out the back, but how could it be that this giant rocket lifts off a launch pad seemingly very smoothly and then goes on a very precise path all the way into orbit, where it releases one or more objects that can stay there for a long time? So the idea of majoring in aerospace engineering is that you learn enough about both of those that they're no longer a mystery. No witchcraft, no magic, just careful engineering that has allowed all of us to leave the surface of the earth, go up into the sky, or potentially even go into space. So the aeronautics side of this is the science, which leads from physics, math, and other subjects, and the engineering, which talks about what gadget is it that you're actually thinking about and how can we make it better. And so what you're going to be doing in aeronautics is thinking about wings. How do they help us magically lift the aircraft such that we don't have to use a lot of fuel just to counter the weight, because we don't have the gear or the legs of the aircraft on Earth? And what missions can we have, right? Shown here are like things that are really high in the atmosphere, regular commercial jets, fighter jet, but there's a lot more, right? Many of you may have bought a quadcopter or hexacopter or whatever and taken it out and effortlessly just kind of pushed a button, had it go into the sky, and it seems really easy. Well, that quadcopter may look really easy, but it represents decades of engineering, just like the other airplanes do. And so you're going to study the structure, the aerodynamics, the propulsion, how they all fit together, and then thinking about the systems and how aircraft work together in the sky and share airports as part of aerospace engineering. The astronautics side of it, which is tied in, aerospace is aeronautics and space. For that, we think beyond the atmosphere. Well, certainly, Earth has a lot of mass, and from Newton's law of gravitation, we know that that means that we have to do something that involves applying a lot of force to get any object off the Earth, carry it into orbit, and possibly go to other planets in the solar system or objects. And so what we look at here is the technology that is required to design a rocket that allows us to propel ourselves from the surface of the Earth all the way into space and release objects. We look at what happens once we get into space. What are those spacecraft going to do? What is their sensor? What is their mission? What is their ability to communicate with people on Earth? And we also look beyond Earth's atmosphere. Certainly, we will be putting more objects on the moon and Mars in coming years, and maybe even people. And to lead up to that, we have to design and fly bigger, heavier, faster rockets and make them more resilient. Because you can't fix a spacecraft that is orbiting Mars. There's no mechanic that is going to come. And so you have to build it right, and you have to operate it well. So a lot of people go into aerospace engineering thinking, hey, I'm going to design a vehicle, and you're going to be part of a team, right? Nobody's going to put you in a room and say, hey, you, all by yourself, design a vehicle. It's going to be more fun than that. Instead, you're going to start learning about the designs that have been built before, and then saying, how can I make it better? How can I have a slightly different mission for it that is more flexible, more efficient, more effective at its mission? We don't always have people on board, so for whether it's a rocket or an aircraft, way back a long time ago, we needed a person to serve as the pilot, to do everything, to incorporate the sensory information that a human has and activate the controls. Now we have thousands of sensors that are giving us that information for everything. And in space, that's really pretty essential, because even though you have really good situational awareness when you're sitting in a chair, walking out of the auditorium, leaving the building, going across the drill field and beyond, when you get into space, your body becomes very confused because there's not even gravity. So you're floating around and you are relying on that space vehicle to keep you alive. All astronauts, no matter where they came from or their mission, rely on aerospace engineers to survive. So do pilots. People do not survive well in the aerospace domains, but they sure are cool. So we want to send ourselves there to learn more about how we can thrive in space and on other planets, as well as to go fast from here to another continent. So I have some cartoons here. Well, the reality is, one of the things that distinguishes the aerospace engineer from the specialized mechanical engineer, and I said that carefully, you can be anything you want if you get a degree in aerospace engineering, so do not listen to those people that say maybe you should be more flexible by going into mechanical engineering. The background is the same. The applications in aerospace are just a little different. You get off the Earth, you look at 3 dimensions, you look at going outside the atmosphere. So if you look at all of these pictures, what you're seeing is, well, we're going to analyze physics. Well, guess what? You've already done that, but we're going to think more about orbits and transfers from the surface of the Earth into orbit, from one orbit to another. How do a string of satellites, like Starlink, for example, effectively orbit for a period of years to provide continuous coverage of the entire Earth? And then once we get to a place like Mars, how do we very precisely, even though we don't understand the atmosphere all that well, go down through the atmosphere and land softly so that we can conduct our mission? We're going to cover fundamental courses. The 3 fundamental disciplines that we have as pillars, so to speak, in aerospace engineering are aerodynamics, both low and high speed, where high speed can even be hypersonic, and we have both simulation and experimental capabilities in that. Low speed would be for things like multicopters up through subsonic airplanes. Dynamics control, how do we take all those sensors and all of the control actuation and motors that we have on these vehicles and make sense of where the vehicle is going to go and when? If you get it wrong on launch or transferring to another orbit, your mission is lost. These calculations have to be done to great precision, and it's pretty exciting to be part of that chain of calculations. Structural analysis and design. It's very hard to carry weight into the air and space. We want to minimize it, but maintain the strength and the longevity that we want for a mission that might last for years in space, or an aircraft that we expect to go through cycles from the surface of the Earth up to high altitude over and over, thousands and thousands of times. So we have to understand not only how to make sure that the aircraft or the spacecraft is strong enough for the first mission, but how in 30 years, 40 years, like with some of the aircraft that the Army and the Air Force have, we can look at them and say, well, we can't retire this. It may be 50 years old, but its structure is fine. So we hope to do that today, just like we did many years ago. Once we think about all of these different systems, then we want to put them all together and design a vehicle that serves its mission and makes sense. And I'll tell you, any of these tests that you go on, it is pretty cool to stand beside a vehicle that launches into the air or heads from Earth into space for the first time. There's not much cooler. And every day I hope that I hear from students or that I can have the opportunity to watch some of these myself. So like with the other majors, we prioritize having students able to do what they want to do, not only in the classroom, but through projects. So this particular slide is talking about undergraduate research. A lot of our faculty work with undergrad students, often with graduate students as well, in real-world experimental facilities to make the most of the education beyond the classroom and the homework. We also have a lot of design teams. A lot of the ones that you see here, this is both aerospace and ocean, are in a facility called the Advanced Engineering Design Lab, arguably now the Aerospace Engineering Design Lab because it is managed by aerospace. We have a number of rocket teams, so if you want to get your hands on a rocket as an undergrad, there are several choices. We have aircraft teams like Design, Build, Fly in the Ware Lab, 3D printed aircraft, wind turbine, and so on. And the students really have the opportunity to go from first and second year where you're really kind of going in going, how do I do this? I don't know the engineering yet, all the way up to the senior year where you mentor like you were mentored by working with other students. So I know those of you that went to Gobblerfest or those of you that have already joined a team are seeing the very beginnings of that. It's never too soon to join a team and to be active. And in aerospace engineering, we have a lot of choices. Reach out to either a peer or to somebody, including me, if you want any more information on how to choose a team or how to connect with them. We also have organizations that are the professional society, like Dr. Gilbert was mentioning ASNE for the naval architectures and naval engineering. And for us, there's AIAA, the American Institute of Aeronautics and Astronautics, and others, where our students are extremely active in conferences, including going to the conferences in undergrad if it becomes an interest of yours. Graduate school, this slide is very much like the ocean slide. Let me talk about careers a little bit. The state of Virginia in aerospace engineering hosts a large number of aerospace companies, especially in the Northern Virginia area. You may be hearing, well, you know, some aerospace engineers are looking for jobs right now, but we have a very big shift toward the defense sector, and aerospace engineering is front and center of the opportunities that we're going to have. You want to fly faster, you want to fly higher, you want to put more objects into space to observe, and you want to go beyond. So the Aerospace Defense and Intelligence Career Fair, I believe, is coming up next week. Make sure you stop by and talk to some people. I know that you're not kind of senior students with a lot behind you, but sometimes they're looking for young students with a lot of energy as well. A lot of companies, this is not a complete list of who hires our students. Finally, I want to mention our undergraduate advisors. We have such a great team of 3 undergrad advisors. They are available in person, they're available on Zoom, and they track every student's progress through the program and are willing to chat and happy to chat anytime. And with that, I've probably used more than 10 minutes, so let's go to Q&A.
Excellent. Thank you all very much. Okay, so to get us started with the Q&A panel, I thought it'd be appropriate for you to do maybe a round of introductions if you weren't here presenting, or even just reintroduce yourself, and then we'll get started with the questions. And I'll start with you, ISC. Now, a few rules about the mics for tonight. You can leave them exactly where they're at, but you will need to push the little button to unmute the mic, and then you'll do that after you talk, and then, of course, turn it off after you talk. Okay, perfect. Sounds good. We'll start with you and ISC.
All right, hi again, I'm Natalie Chewbacca, I'm a faculty member in ISE.
I'm Bella Princey, I'm a senior in ISE.
Hello, Rohit Pandey, Assistant Professor, Mining and Minerals Engineering.
I'm Katie Bottom, and I'm a senior in the Mining Engineering Department.
Hi, Ella Atkins, Department Head and Professor, Aerospace and Ocean Engineering.
And I'm Maggie Campbell, and I am a senior in Ocean Engineering.
Excellent. Thank you all very much. So to get us started with our first question, and we'll start with you in ISC. Why should a student consider your degree? And you can choose to all answer the question, or you can choose to only answer it once at each of your tables.
I would say if a student is kind of trying to figure out what degree they're in for ISE, if you find yourself often thinking about efficiency, enjoy solving problems, love managing teams, people, information, overall just trying to make systems and organizations more efficient, more collaborative, just kind of bringing a lot of value to organizations, systems, places that you're at. That would be a reason why you should consider ISE.
You guys should consider mining engineering if you want a tight-knit family. Our class sizes are very small, and all of our professors know our name. We also, as Rohit said earlier, have a lot of opportunity. So there's a lot of opportunity to travel. The schools send you places throughout your time here. I've been all the way across the country, and that's unique to our department.
I would say that you should consider ocean engineering because honestly, it's really fun. Like, I really enjoy all of my classes. I love my classmates, like, they're great. The faculty is awesome. The class size is pretty small, so like she was talking about for mining engineering, like, you could really get to know your professors, and it's a really personal experience, and there's lots of really unique experiences that I've gotten to have in terms of like the research facilities that we have here for ocean engineering at Tech, and also the design teams that I really don't think you would get to have elsewhere, like scuba diving with a submarine. You don't get that anywhere else, so it's pretty awesome.
Yeah, and I feel like I need to speak for aerospace, but I'll just say aerospace and ocean together are the places where you are truly exploring places that we have not really fully explored yet. There's a lot of the bottom of the ocean, especially at the deeper depths, that we haven't mapped carefully that have some surprises. And now we're thinking about what happens at the bottom of the Arctic Ocean as we get more access to it. And in space, we barely know what goes on places like Moon and Mars. And so it's going to be really exciting to find more there and beyond.
Excellent. So the next question we have for you, and we'll start again with ISE, is what was the neatest aspect of your undergrad experience that you've taken advantage of?
It sounds a little cliche, but getting involved with internships and co-ops and just organizations within Virginia Tech. These are really ways for you to figure out what you like and what you don't like. And for me, I've gotten to do a couple of cool internships that I've gotten through connections within the ISE department or through other organizations geared towards engineering at Virginia Tech. So last summer I got to do an internship in San Diego. This past summer I did an internship in Boston, Massachusetts. So that was really cool. And then right now I just got involved with my senior design, and that has been a highlight of my year so far. I just got to have a meeting with the co-CEO of the company that's sponsoring my project, and he just had us all so excited about the work that we're going to get into this year. So that has probably been my favorite part so far of this year, and there's really just so much you can do with ISE in so many different industries. So I think that is a lot, but it's probably the neatest part of my experience is getting those real world experiences within your degree.
I would say that, I feel the same way. The neatest experiences that I've had is in the field and internships. I have had the honor to have 3 internships under my belt before I go into full-time, which is very possible for you guys. I would really consider it. I have gotten to travel all around. I went Chicago, Illinois my first summer. I went Western Kentucky, right on the Tennessee border. And last summer, I was in Alaska working, and it was just unreal. Part of my internship that I do have to highlight, I did get to push the detonator for like a blast you guys saw earlier, which is an opportunity. So I think that would be the neatest part.
I just want to pitch in here. I'm not an undergraduate student, but I hear some whispers. They are not talking about hanging around in tots. So sometimes just hanging around outside of class, I'm sure like students are always talking about that. That's the fact that I think being a tight-knit community, the students are also having fun. And I think everyone should have fun while they're here. So I think that's one thing. I just want to put it out there.
I also participated in like internships and stuff, and I definitely recommend like that. I got a lot of really great hands-on experience and got to get on the water a lot for ocean engineering. But I'm actually going to take a little bit of a different spin on this and say like, for me it was the like extracurriculars that I got involved in while I was here. I could not recommend enough like getting involved in a design team or research and finding something that is outside of class where you're actually able to apply all of the skills that you're learning in class and see how useful and how applicable they really are. Like, I took math classes and I was like, oh, I'm never going to use this. Well, lo and behold, I actually did. And so, like, I would say that's been the neatest thing, is to actually get the experience of like doing research or doing those design teams and being in charge of a project and getting to make those decisions and using the skills that I learned in class and being able to transfer them from the classroom setting to a hands-on experience.
Perfect, thank you. So the next question we have is, as students are trying to determine the best degree for them, what is one piece of advice you would give them to help make that decision?
Sure. I would definitely think about the industries that you're interested in, but not to necessarily think of the degree as a means to an end of that, to be in that industry. So there's a lot of different roles that you can have within working. Say, if you are interested in working on planes or cars, there's so many different types of engineers that work in those spaces. So to really look at the value you can add through kind of looking through the courses that you're going to take, and then kind of taking the chance to look at those courses and try out different things to see where you really find your passions within that, if that kind of makes sense. If you'd like
Sure,
to add
yeah,
something else.
I'll add a little bit. I got some good advice that was given to myself when choosing a career. If you think of it as a Venn diagram, where it's you want to find that intersection of something you can make money at, make a living at, which you'll all be fine if you get a degree from here in engineering. The second piece would be something that you enjoy, and the third element of the diagram is something that you're good at. So if you can find that piece, that the intersection of those three elements, I think you're golden. And some of the skills, the things that maybe I think people in ISE excel at, people that are good with people, good communicators, good at probability and stats, in general good at math or enjoy data and math, and creativity. I think those are some of the skills that people in ISE tend to really leverage and thrive in that environment.
That was a really good response. He kind of just stole the floor there. I would honestly agree. I would say anything you're good at, you're going to find that you enjoy it a little bit more. So going into something that you truly enjoy, this is what you're going to do for many years of your life, which is hard to decide what you want to do now, but find something that you do enjoy, something you want to go and you want to show up every day for work, you want to be there. For mining specifically, it's like there's a lot of people. I love people, and that's why I love mining. There are all kinds of people, so just do something you love.
I would say I probably want to reiterate what Dr. Atkins was kind of saying earlier, and like, especially for ocean engineering, I've talked to a bunch of like freshmen in the past who are like, oh, like I don't know if I want to commit to that. Like, what if it's too niche? Like, what if I'm not, like, what if I decide down the line, like I do ocean engineering or aerospace engineering, that I don't actually want to do like something in that career field. And like, I guess what I would say is like, I know you're learning how to be an engineer, and ultimately like engineers, yes, while you're learning a lot of different backgrounds, like whether like specific types of math or physics or data processing, ultimately you're really learning like a way of thinking and a way of like analyzing. And so you can I would say, do something that you're interested in. Don't be afraid to take the more niche path, because even if you figure out it's not what you want to do like in the future, you're not by picking a major, you're not locking yourself in to that career for the rest of your life. So pick what you're interested in, even if it is a little bit niche, because it might just turn out to be like your favorite thing ever.
So let me add, if you wake up in the morning and you think of a topic and you somehow manage to fit that with your career, follow your dream. because that's what it's going to be. I don't set an alarm clock because I cannot tell you how many mornings, I'm pretty old, I've woken up and I've said, I got to go design an airplane, or I have to go fly an airplane. Twist my arm, make me eat breakfast and leave the house quickly and go do those things. So if you can find that career, it's not going to be work. It's going to be a hobby. It's going to be fun. There's going to be hard stuff, no question about it, including some of the math and stuff that you do. But if you can find that match, follow it. Don't turn back. Make sure that you do what you can to make it happen.
So I think we have time for one more last question, and so we'll skip down to number 5 on your list that you all have. Is what is your favorite thing about your degree?
My favorite thing about ISC is the versatility of the degree. There's so much you can do with it. There's 4 main areas that I think you all heard a bit about, but you really get to touch upon those within your classes and figure out which area you're more interested in. To remind you, those are manufacturing, management systems, operations research, and human factors. So it's a very broad degree, but you really get the chance to specialize within that, and even within your electives. So I would say that's probably my favorite thing, and the variety of the classes that you get to take, because you're really going from a design course to a math course to something with human factors, learning a bit more about psychology behind work. So you really get a lot of variety in your day with the degree and with your classes. So that's probably my favorite thing.
My favorite thing is that there are endless opportunities. Mining is so broad. It's such a niche major, but it's such a broad application. There are so many things you can do with it. It is so hard to pick what you actually want to do and where you want to go and what, your end goal is. So I think that would be my favorite part.
For me, one, I grew up sailing and on the water, and so I really love just getting to go into my classes every day and learn about boats, because I grew up around boats and I really love being on boats. But another really cool thing about my degree that if I take a step back and really think about it is just how ingrained in human history shipbuilding and boats are. If you think about it, our entire society, all of our distribution depends on ships nowadays. The reason we were able to explore and have civilization all over the globe is because of ships. Boats have been around for so much of human history, and so has ocean engineering, even if it didn't go by that name. But even the tall ships that you see in movies, those had to be designed and engineered by someone. So I think it's really cool that I'm joining the ranks of ocean engineers from all of history, and I can kind of look back and see that's where that came from. That's really cool. It's really cool to have that history, and to learn about it in your classes too.
I guess I'll say something about aerospace, but I want to follow on to that, right? Globalization, having a global economy. Aerospace and ocean engineering is really at the center of that. The ships in terms of cargo transport, and the aircraft in terms of sending people very quickly from continent to continent, and the space for giving us the ability to communicate within milliseconds across the globe.
I would like to add one thing. All of this is going to be possible only if you're able to mine. So I think, so that's the best part about mining for me.
Excellent. So give our panelists a round of applause. You all can feel free to exit the stage. I will also give you all an opportunity to go make your way back to your tables. So the departments will have tables set out as you leave the auditorium area, so you all can make your way back to your tables. I'll let the students stay here until you get to the back before I put up the QR code for attendance. Thank you.
Listen to.
So now you're just waiting on me.
Because life is short. Enjoy yourself.
This sandwich, it's a complete game changer.
Hello, this is Mike, and a little thing I love about the Chick-fil-A Pretzel Cheddar Club is that juicy chicken with that toasty pretzel bun. That bun, it's crispy, cozy, just amazing.
If for some
With the
reason you
pretzel
can't
bun, the Dijon
get a
mustard, and
photo of the
chicken,
QR
it
code,
makes
feel
that
free to just
sweet,
come
savory
closer.
kind of combination. It's everything
Thank you
that
all so
love
much
about
for being
food
here
rolled
tonight,
into
but
one.
also thank
It
you those
looks
of you,
phenomenal.
especially who
It
came
tastes
all
great.
4 nights. I
It's
really
delicious.
appreciate it.
Order the
Have a
Pretzel
good
Cheddar
night.
Club
Safe
with cherry
travels.
berry and Sprite for a limited time
Thank
on the
you.
Chick-fil-A app. Real guests paid for their testimonial.